Q4, we have what is the velocity and the acceleration of the mass. So we know how to write the velocity of the simple harmonic motion. A omega negative, don't forget the negative sign, sine omega t, and your omega is, 2 pi over t, period, right? So if you substitute the values, negative 7.5 centimeters for A, and your omega is 2 pi, we take period as 0.44 seconds. So that is your A omega part, and then the sine omega is again 2 pi over 0.44 seconds, and then the t, you have to evaluate the velocity at t equals 0.15 seconds. So you have to substitute here 15 seconds. So this is the equation you have to solve now. Okay, now if you plug these values into your computer, this is what you end up having. Negative 90.09 meters per second. Sorry, centimeters per second. Because we are in centimeter scale right now. That is V. And then the acceleration, okay, do a little line here. Acceleration is, now still it's negative. Negative A omega squared cosine omega t. Now your omega is 2 pi over t. So this is equal to negative 7.5 centimeters times 2 pi over 0.44 seconds cosine 2 pi over 0.44 seconds time 0.15 seconds. So we evaluate the acceleration at 0.15 seconds. So if you put all the numbers in the calculator, you should end up getting positive value here, not negative value. Yes. Square omega. That's right. Good. Right. So you should check your numbers here. I got 826.84 centimeter per square second. This is what I got when I do it. Okay, so you should check your numbers. And then the second part. What is the total energy of the spring mass system? Now we know the total energy. How do you write the total energy? We proved this in the class. Either it is half mv max squared or half half a amplitude, half ka squared. Now this is the maximum potential energy you can have. Maximum potential energy. And this is the maximum kinetic energy. Maximum kinetic energy. Okay, so if it says the energy of the system, you have to calculate one of them, not both. Because maximum, you can have maximum potential energy and maximum kinetic energy together. You can, right? Okay, if I draw the spring mass system here, so you have the equilibrium position of the mass, and at this point you have maximum amplitude from here to here A. Here you get V max. This is x equals 0. This is x equals A. Here x equals minus A. Okay, so at this point you will see here, at this point you will see maximum velocity, and at this point you will see maximum kinetic energy. At this point kinetic energy is 0, but you have potential energy here. At this point you have maximum potential energy, kinetic energy is 0. At this point you have maximum kinetic energy, potential energy is 0. because spring is not stretch. Spring is in equilibrium. So you have maximum kinetic energy here, right? So when you ask to find the total energy of the system, either this one or this one, you have to calculate, right? So which one you're going to calculate? So E total is equal to, what is the amplitude? You know the amplitude. Now, what is K? K is given in your problem. K is given as 245 Newton per meter. So half K amplitude squared. So half times 245 Newton meter times 0.75. Oh, you can do, it's not 0.75, it's 0.075. So we have, because you need to put this in meter. Because the spring constant given in Newton per meter, you have to substitute it in meters for 0.075 meters squared. So which is equal to 0.075